Hello everyone, this is Nidhi Goyal, Assistant Professor at KIET Group of Institute. Today in this video, we'll be discussing about the Byzantine general problem. So this is also one of the algorithm, or we can say this is a consensus protocol. We have already discussed about the RAFT and the PEXOS. So the other and the most powerful algorithms is the Byzantine algorithm. For that, first we have to understand what is Byzantine general problem is. So Byzantine general problem is, let us talk about the scenario where let's say in the 80s, a decade ago, where there is no mode of communication, where there was no social media, or where there is no mobile phones, there is no mode for the communication. For example, let's say we have a different countries, let's say ABC. All right, so C is the more powerful country and A and B wants to attack C. All right, A and B, no, individually they cannot attack on C because C is powerful from them. So why not A and B put to attack together and defeat the C? So how the communication can happen between A and B? There was no mode, as I said before. So the only thing what they can do is they can send a message through a person to B. Let's say A is sending a message, okay, let's attack on C on Thursday. All right, now based on that, B will reply. All right, now just imagine what happened to that person who is taking the message from A to B. Maybe in between it may got lost, or it may can die, or it can be the message can be manipulated in between them. So these are the problem that the A and B can face between for communicating each other, right? Maybe the messenger who was sending, the person who is taking the message to B, might be like sent, but on coming back from by taking the reply from B. Maybe that time message can be like dropped, or can be miss, or can be a communication cannot happen for XYZ reason, right? So how this problem can be overcome, how this can, I'm talking about then when there's no mode of communication, right? So same problem when we take the scenario of today, when we have everything, but when we talk about the distributed network. Of course, so every peer has to, every peer has to communicate the message to every peer in the network. All right, so let's say there are thousands of the peers in the network, and one of the peer is broadcasting some message. All right, and majority of the peers not receive the message just because some network problem, or some kind of anything can happen on this. So how this problem can be resolved? uh, uh, that kind of a problem. So for that we have this. This is what the Byzantine general problem is all about. So let us take an example just to be more clear on this. What is the Byzantine general problem? Let us consider that we have a commander and we have the two lieutenants, let's say, and they are communicating with each other. All right. So let's say commander has sent some message to the lieutenant 1 and lieutenant 2. So basically, the commander can instruct them whether they have to attack the castle or not, or they have to retreat. All right. So initially, let's say in the round one, the commander sends the correct message to the lieutenant one and lieutenant two. Let's retreat message to both of them. All right. So based on the message received by the commander, lieutenant one sends a message to the lieutenant two for the retreat message. But lieutenant two somehow manipulate the message, or we can say the lieutenant two is we are considering as the faulty processor. So how come the lieutenant two is sending message to the lieutenant one as an attack, right? So now if I talk about the lieutenant one, so lieutenant one receives two messages, one as a retreat from the commander, and 2 from attack from the Lieutenant 2. Also remember, when whoever receives the message will know who sends the message. That means the Lieutenant 1 knows what message is sent by the commander and what message is sent by the Lieutenant 2. The identity is already maintained here. So whoever sends the message, the receiver knows the sender's identity. That is for sure. Now, Lieutenant 1 receives the two messages, one for the retreat and another from the attack. Now, based on what condition Lieutenant will agree to one message? Alright, now he is a bit confused whether the retreat is the correct message or attack is the correct message. As I said, based on this, Lieutenant 1 knows that okay, the commander is sending the message as a retreat, so commander is might be correct, not the Lieutenant 2. So he will be considered that the commander's message is the correct message. So based on that, Lieutenant 1 has decided. Lieutenant 2 has two messages received, both are retreat. So Lieutenant 2 means Lieutenant 2 knows that the correct message is the retreat message. The complete network, if I can say, the commander, Lieutenant and Lieutenant 2 is agreeing on the one message that is a retreat message in this scenario. Let us say, let us consider if commander isn't faulty. Let's say the commander sends a message to Lieutenant 1 as retreat, but the Lieutenant 2, it sends the message as the attack. Now what will happen? Lieutenant 1 will send a message to Lieutenant 2 as retreat, because whatever the commander will send a message, Lieutenant 1 will send to other Lieutenant 2 also. Same with Lieutenant 2, as Lieutenant 2 is not a faulty here, Lieutenant 2 will send the same message whatever he received from the commander, and commander sends the attack message. Right, now the Lieutenant 2 will send the message to Lieutenant 1 as attack. Now, how this agreement can be done in this kind of a scenario, where commander is only the faulty. According to the Lieutenant 2, it will decide on that commander, whatever the commander has sent the message will be the correct message. So Lieutenant 2 will be agreeing on the message called attack, and Lieutenant 1 will be agreeing on the message called retreat. Right, now how the decision will be take place here. This complete agreement is goes off because there is no single value where all the three are agreeing to it. So here this problem comes up. Now let us consider how this can be solved by considering one more lieutenant in the network. Let's say there is one more Lieutenant 3 in this network. Now what happens? Take the scenario 1, where commander sends a message to each Lieutenant 1, 2 and 3. Lieutenant 1 and Lieutenant 3 echo the correct message whatever the commander sends to others. Lieutenant 2 incorrectly echoes to the others, because here we are considering as the Lieutenant 2 as a faulty one. Now, on what basis the complete network will agree on the same value? So we'll be taking as Lieutenant 1. Lieutenant 1 will be saying will check out what all messages it will got, and majority of the messages, if it is a retreat, it will agreeing on the retreat. If the messages on maximum of the messages of attack, then it will agreeing on the attack. This is how the decision going to happen. This is how the decision will be going to take place. All right, now Lieutenant decides on, as I said, Lieutenant decides on majority of this. So whatever the Lieutenant 1 will going to receive, Lieutenant 1 received one retreat message from the commander, one retreat message from the Lieutenant 3, and the attack message from the Lieutenant 2. So 2 retreat and 1 attack. So majority is for the retreat. So Lieutenant 1 will be agreeing on the retreat message. Same goes with the Lieutenant 3. So he is also agreeing with the retweet message. Alright, now Lieutenant 2, if I talk about the Lieutenant 2, all three messages what he receives is the retreat message. So all the three lieutenants is agreeing on the same agreement with a single value. So the network is been agreeing to the single value. So there is no such a problem, even though there is a one faulty processor, or can say one faulty lieutenant. All right. So if there is one faulty system in the network, the entire network is still the consistent one, right? That is what conclusion we can say. If there are four peers in the network and one is faulty, okay, there is no problem in maintaining the consistency of the system. And if for example, if there are four peers and there are two faulty, and of course the decision will not be taken in that case. Yes, if there are four peers and there are two faulties, then decision will not happen. You will not be in the same agreement. So here the system will not be considered as consistent one, right? So here is the another scenario where we have the four peers, but the here we are considering as the commander as the faulty one, right? So commander sends different message to the lieutenant. For example, lieutenant 1 receives the retreat and commander send lieutenant 3 as a retreat, but for the lieutenant 2 it sends the message as the attack. Now lieutenant 1 and 2 and 3 correctly echoes to the message to the other. Whatever they receive from the commander, they just echoes to each other. All right. Now, Lieutenant 1, how the Lieutenant 1 decide that what message he received and what he has to agree on. So, based on the majority, of course, just see the diagram and check it out. What all the messages it is receiving. It is receiving as a retweet message from lieutenant 3 and attack message on the from the lieutenant 2. So majority is the retreat one. So lieutenant 1 decides on the retreat. Same with the lieutenant 2. The lieutenant 2 will decide on the majority. That will be the retreat one. Same with now goes on the lieutenant 3. Lieutenant 3 decides on the majority. As I said, all the receiving messages from commander, lieutenant 1 and lieutenant 2. So retreat, and attack. So it will also comes up with the retreat message. So in a nutshell, what we can say that if there are four peers in the same network, right, and one of them is a faulty one, so the complete system will not go off. The image, the consistency of the system is still we can maintain the consistency in the system, right? Now, so the consistency and inconsistency, on what basis we are deciding how much, if there are, as I said, if there are four peers and one is faulty, the system is consistent. So minimum of what kind of a faulty system a network can achieve. For that we have the Lampert-Shaw-Peace algorithm. So what this algorithm says. So Lampert says, this algorithm says, for example, there are n processors in the system and n processors, or we can say the nodes, or we can say the systems over here. And m of them are the faulty. So we can say the system is the consistent if we have the faulty number of the faulty system which a network can exist, let's n minus of 1 by 3, the flooring value. So this is the maximum limit where a system can have the faulty system. I mean the network can have that much of faulty system. Let's say for example, what we have discussed till now, that if there are four peers in the network, just put it on the, let's say there are four processors. So 4 minus of 1 divided by 3. So 3 by 3 is 1. So maximum one faulty in the entire network, one faulty processor, uh, 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 one faulty processor can be there in one system, which will not affect the entire network, right? If there is two, the entire network will go off. There will not be any single value where all the peers can agree to the same single value. So that's what the Lampert short piece algorithm says. So that's what you have to learn about the Lampert shape. So that's what the Byzantine general problem and Lamport-Shostak piece algorithm. So let me sum up with all this general problem. The general problem is about the communication between the peers in the network. Usually it happens, this problem occurs when there is a distributed system. Yes, and yes, the blockchain is completely distributed, so we can face this kind of a problem in a blockchain. So how we can resolve it, and how much how we can say that our system is a consistent, for that we have the Lampert. So there is some kind of a communication between all the peers, and the communication can be lag based on where the system can be crash or system can be fault, or the complete system will go off. So how we can manage this? We can manage based on the majority of the message received by the all the peers. Based on that, we take the decision. So that is what the Byzantine general problem and Byzantine algorithms. That's all for today. Thank you for watching it. If you have any doubt regarding the Byzantine, you can mail me or you can comment below. Thank you.